Alright guys, today's goal is to, the learner will, understand solving problems with trigonometry. So solve for A. Well, that should be a right triangle. So let's see, we have, if I pick this one, I have adjacent over hypotenuse, so I get cosine of 23 degrees equals 3 over A. So A equals 3 over the cosine of 23. So just make sure your calculator is in degrees. 3 divided by the cosine of 23. A is 3.26. Okay? Find the complement. Remember, complement are angles, two angles that add to 90 degrees, so 43. Supplement are two angles that add to 180, so 133. Yep. State the bearing that describes the direction northwest, so degree-wise, northwest. What is perfectly northwest? Well, that's the 45-degree angle there, so it would be 135 degrees. State the amplitude of the sinusoid. The amplitude is 3. So let's see. What did I do wrong there? Because I did something wrong. Cosine of 23, adjacent over hypotenuse. Oh, that's why. Because I should be using the 23-degree angle, so I actually have opposite over hypotenuse. So the sine of 23 equals 3 over A. So you got to do 3 divided by the sine of 23. See, this is why we check. So A equals 7.68. Okay. 43, 133, 135. Oh, I didn't see the period question there, so I didn't read. We need to remember to finish reading. So we found the amplitude, the period. Remember, you do 2 pi divided by B. So it's pi. Okay. So what you learn about? More right triangle problems, and then simple harmonic motion, and why these problems illustrate some of the better known applications of trigonometry. Okay, an angle of elevation is the angle through which the eye moves up from the horizontal look at something above. An angle of depression is the angle through which the eye moves down to look at something. So here's your angle of elevation right in here. Here's the angle of depression. Okay? So the angle of elevation from the buoy to the top of the, I don't even know how to pronounce that. If someone does, Barnegat Bay Lighthouse, 130 feet above the surface water is 5 degrees. Find the distance from the base of the lighthouse to the buoy. So we have adjacent and opposite. So tangent of 5 degrees. I don't know why I'm circling the 5. Tangent of 5 degrees equals opposite over adjacent. So that would be, so 130 divided by the tangent of 5. X would be 1,485.91 feet. There you go. Remember though, we agreed on hundredths. That's why I did the hundredths. Alright, simple harmonic motion. A point moving on a number line is simple harmonic motion. If its directed distance d from the origin is given by either A, sine of the WT, I'm going to have to look up, I forget what Greek symbol that is theta, you know, it's one of those, but or d cosine, where a and w are real numbers, and the w always has to be greater than 0, and the motion has a frequency of w divided by 2 pi, which is the number of oscillations per minute, or per unit of time. Alright, so a mass oscillating up and down on the bottom of a spring, assuming perfect elasticity and no friction of air resistance, can be modeled as harmonic motion if the weight is displaced a maximum of 4 centimeters. Find the modeling equation if it takes 3 seconds to complete one cycle. Alright, so here's the thing. We have to assume that it's oscillating starting at 0. So which function starts at 0? Sine. So we're going to be using this. Now A is the amplitude. It says it has a displaced at a maximum of 4 centimeters. So we know A is 4. And it says it takes 3 seconds to complete one cycle. Well, that means the period is 3. But we're not looking for the period, are we? So, and we're not really looking for B, because the equation that we have, this is the frequency is W divided by 2 pi. Okay? So we have to find the frequency. Well, the frequency is equal to B divided by 2 pi. So we have to find B. Well, if the period is 3, then B is 2 pi divided by 3. Well, so if we put that into here, you get 2 pi over 3 divided by 2 pi, which is 1/3. Okay? So the frequency is 1/3. So if we look, the frequency of this, though, is equal to W over 2 pi. So how would I solve that for W? Multiply by the 2 pi. So I get W equals 2 pi over 3. So we have Y equals 4 times the sine 2 pi over 3 times T for time. Okay, let's see. There we go. Alright, see you guys in class.